Hello and good afternoon, CSI158, Section 841 and 847 students for the second 8-week term in the spring 2014 semester for the Cisco Networking Academy curriculum for routing and switching essentials. Today's PacketTracer tutorial is going to be on PacketTracer activity 9.5.2.6, and we're going to take a look. There are a number of typos in here, right? And we're going to take a look at some of these, and this is a good opportunity to get some troubleshooting experience. So we've got our addressing table. We're going to be configuring IPv6 ACLs. And let's go ahead and jump right in here, because this is going to be based off some of the typos that exist in here. This could be a little difficult to sort out, but I'm going to reference some pages in the text that can help you along the way. And so let's take a look at our scenario. So logs indicate that a computer on the 2001 DB8:1:11:0, and that's this network right here off of this router interface, the gig 01 interface on router 1. And we only have one PC here, but the assumption is that there could be hundreds of PCs that are back here. And it looks like they're accessing the web page, constantly refreshing the web page, which is considered a denial of service attack on server 3, which is over here on the 2001 DB8:1:30 subnet. And let's see what it's asking us to do. So until the client can be identified and cleaned, you must block HTTP and HTTP access to that network with an access list. All right, so let's configure that access list. So step 1 says configure an ACL that will block HTTP and HTTPS access. And the ACL should be named block HTTP on router 1 with the following statements. Now it tells you what the name of the ACL should be, but we're going to see that what happens here is it's going to be a little different than what's shown. So let's go ahead, let's pull router 1 up. Whoops. And there's our error message. So we're going to pull router 1 up here. We'll get started from user exec into privilege exec, and we're going to switch into global config mode. Now you'll notice it says configure an ACL named block_HTTP, and we know that that's got to be an IPv6 ACL. So if I type IPv6 access list, and if I do the question mark, you'll see that it's going to ask for the name, right? And so this is where I would type in block_HTTP. So now that we have that in there, we actually have the named access list, IPv6 access list, block_HTTP. Now it didn't show you how to do this, but it's assumed that you're going to have to create that access list. Now, here's where it can become confusing. If you made the assumption that this was going to tell you every step that you needed to do, you would have then thought that you would jump to this prompt here, global config mode, and that you would have entered in your deny statements. However, if we create the named IPv6 access list, you can see that we're entered into a sub-configuration mode, which is IPv6 ACL, which does not look anything like the global config prompt we have here. In fact, I'm going to show you that these commands here will not work from global config mode, right? So these are in error. These are a mistake right here. So let's go ahead now and let's configure the access list similar to what they're showing. So if I do the question mark, you can see that now we have a deny, and I can also do my TCP any host 2001:DB8:1:30:30 equal www. All right, and you can see they have the established there as well, but we're only doing the blockage of the traffic. So we're not interested in allowing that traffic through. The next statement will be deny TCP any host, and it's going to be, in fact, we can save ourselves some time. So it's going to be the exact same statement except HTTPS, which is simply port number 443. And then the final thing says allow all other IPv6 traffic to pass. And this is critical because this access list that we've created right now denies HTTP traffic, then it denies HTTPS traffic. Nowhere in here are we saying, hey, let's allow all other traffic through. And so then remember, an access control list by default, the last statement, which is implied, right, or it's an implicit deny all. And so it would deny everything. And so what we want to do is we want to permit IPv6 traffic any, right? So we've denied what we need to deny. Now we need to make sure that everything else is going to be able to get through and we're not going to have any issues. So if you were to look at page 627 in your Routing and Switching Essentials textbook, there's a great example of how you would go about creating an IPv6 ACL inside of a topology that looks almost identical to the topology that we are dealing with here. And really the only difference, other than some of the, and in fact, in looking at this, actually the subnets are almost identical as well. So the topology is very similar to this. Server 3 is just a PC, but again, it'll give you a much better idea as to what you need to do. And so you'll see here that the mistake is actually in the prompt that they're showing. They're showing you the global config prompt here. The prompt you're going to see is the sub configuration mode for IPv6 ACL. And so that's really where the mistake is at, and that's how you would sort this out. All right. So as you can see right now, our completion percentage, we're 40 out of 100. So let's continue on here. So we're going to allow all traffic through, which we did. I'm going to go ahead and type exit, because now we need to go to the interface on router 1, which is going to be, it's going to be an inbound ACL. And so that interface is going to be this interface right here, which is going to be, let me click in here, gig 01, because again, it's coming off of this network here. So gig 01, so let's go interface gigabit Ethernet 0/1, and then we'll slide back over to complete the exercise. So IPv6, and this is a traffic filter. Remember, it's not access group or access class, it's traffic filter. And we're going to put the name of our filter, whoops, HTTP, and inbound. And so we're going to apply that to the inbound interface. Okay, so we've created our named ACL, our IPv6 named ACL. We've applied that to an interface, and now I'm going to do a write mem and save that information. And so now what it wants us to do is verify the ACL implementation. So let's close this down. So open a web browser on PC1, and this traffic should flow. We shouldn't have any issues here. So let's check it out. So let's type in, and in fact, I can grab, it'll allow me to copy, no? All right, let's see if we got, nope, definitely not it. Let's scroll back over that. That was in my buffer. So we'll do HTTP colon / and then we're going to do 2001 colon DB8 colon 1 colon 30 colon 30. And that works perfectly. Let's try HTTPS and go, and that also works. So now I'm going to copy this here. All right, so that was PC1, and we're not having any issues at all. So PC1 works great. Now PC2, this is the subnet where we're experiencing issues. And so this is where we applied our ACL. So let's jump into the web browser, and first we'll try HTTPS. Right, and as you can see, it's not working. We've clicked it a few times. Let's try HTTP. And again, we're actually getting nothing, right? It's not showing us anything. And so the website is not displaying. So we can assume from that output that that was a successful application of that ACL. Let's go on to router 1, and let's do a show access lists. Okay, and so here is our access list for IPv6. It shows we're denying www, which is HTTP, and then HTTPS is 443, and we have a series of matches. Not only do we have matches for HTTP, but we also have matches for HTTPS where this is being denied, right? Okay. So let's move on to configure, apply, and verify a second IPv6 ACL. So the logs now indicate that your server is receiving pings from many different IPv6 addresses in a distributed denial of service attack. So we need to filter ICMP ping requests, and we're going to go ahead and do that. Let's get rid of this message here. So we're going to go ahead and do that, and it's going to be on router 3. All right, so let's go ahead and pull up router 3. And we're going to pull the CLI up here. We're going to go from user exec into privilege exec, and then into global config mode, right? And now here, it doesn't actually tell you the steps that you need to execute one by one, or it doesn't actually write them out. And in fact, there are no typos here, so that's also a good thing. All right, so let's take a look at the requirements. So create an access list to block ICMP. So we're going to configure an ACL named block ICMP on router 3 with the following statements. And so here's what that's going to look like. So again, we're going to say IPv6 access list. All right, and then the word, right? So what is the name? So it's going to be block underscore ICMP. And now we hit enter and we go into the sub configuration mode for IPv6 ACLs. So let's take a look. It says block all ICMP traffic from any hosts to any destination. Okay, so we're going to go ahead and do deny, and let's do a question, or what should be IPv6, right? So IPv6 question mark. Now, you'll notice when we did the question mark, you could do ICMP all by itself. So let's go ahead and back up here and do the question mark, and let's say deny ICMP. And if I do a question mark, we do any to any, right? So again, because the requirement is block all ICMP traffic from any hosts to any destination. And then we'll do the question mark. And so that should work just fine. So we're denying all ICMP traffic. And then it says allow all other IPv6 traffic to pass. And so that was we've seen this before, and it's also on page 627 in your text. Permit IPv6 any, and we'll do the question mark, and then we're good. So we're blocking all ICMP traffic. However, we're allowing all other IPv6 traffic to pass. So we'll type end. All right, now it says apply the ACL to the correct interface. So in this case, ICMP traffic can come from any source. To ensure that ICMP traffic is blocked regardless of its source or changes that occur to the network topology, apply the ACL closest to the destination, right? And so the destination network, let's go back here, and says logs now indicate that the server, right, which is our web server, is receiving pings from many different IPv6 addresses in a distributed denial of service attack. You must filter ICMP ping requests to your server. So we're going to do that, and down here it's telling us apply that ACL closest to the destination. Well, the destination is going to be router 3's interface here, which should be the, and let me mouse over it here. Whoops. It's going to be the gig 11 interface, and let's double check that on router 3 here. Let's do a quick show run, and let's make sure that that's the right interface, because it should be the gig 00, it looks like. So 2001 DB8:1:30::1. So it's going to be this interface right here. You'll notice we also have EIGRP running on this specific interface. And so we're going to apply that to gig 00. And there's our serial link out of the network. And there's our EIGRP statement with the router ID. Okay, so closest to the destination, right? And again, the destination here is our server. And so let's go ahead and go config T. We're going to go into interface gigabit Ethernet 0/0. And this is where we're now actually going to apply that traffic class that we looked at, right? The traffic filter that we looked at earlier. So IPv6 traffic filter, and this is where we put the name of our filter, which is block underscore ICMP. And then what direction, and this is critical, is it an inbound or an outbound? So remember, the problem is we have traffic from these subnets over here, right, or subnet PC2 subnet. Traffic is coming this way, right? Whoops. So traffic is coming this way. It's coming through the router, right, through router 3, and then down to server 3. And so when you look at that, that traffic will have to come inbound on the serial interface. However, remember our definition of inbound and outbound. If we wanted to block it here on the serial interface, that would be inbound. However, once the traffic enters router 3, and router 3 has to buffer that traffic, it has to make a routing decision based on that traffic, the source and destination IP address, and then internally switch it out another interface. The traffic is now coming out of router 3. And remember, it's from the perspective of router 3. So if it was over here on this interface where we applied it, we would say that's inbound because it's coming into router 3. However, once router 3 receives that traffic, has to internally switch it and send it outbound, then it's outbound traffic. So we're going to go ahead and apply this, and let's check and see if we get this right. We're going to apply this in the outbound direction. And so let's see if our total increments, and yes, it just incremented to 100. So again, this is one of the very critical subtleties of access control lists that you definitely need to have an understanding of. And that is the difference between an inbound ACL, right? So if the traffic was coming this way and I wanted to block it inbound, we could block it here. But however, it's outbound traffic because it's coming into router 3, and we're applying that access list to an interface on router 3. So at that point, it becomes, what does it look like from router 3's perspective? Is it inbound traffic, which router 3 has not processed internally in terms of making a routing decision and then internally switching it to a different interface? Or is it just traffic that's showing up on router 3's interface here for the first time, right? So again, it's inbound if the router on which you're applying that interface, from that router's perspective, it's inbound traffic if that router has not made a routing decision and has not internally switched that traffic to send it out a different interface. It's outbound traffic if the router on which you're making that configuration inbound or outbound decision on, it's outbound traffic if the traffic has been buffered by the router and the router is making a routing decision and then internally switching that traffic out a different interface. And that's what we have here. Because remember, all of that traffic is showing up from these different networks, or we're anticipating that it could be. And so we want to apply it as close to the destination as possible. Therefore, it's going to be an outbound ACL. All right, so hopefully that clarifies the difference between inbound and outbound based off of the interface on which you're applying that ACL. And again, remember, it's from the perspective of the router on which you're applying that ACL, and then based on the interface that you're applying it to. All right, so let's do a write mem. So we're going to save that off, and let's take a peek over here. All right, so we're 100 out of 100, and now we're going to verify that the proper access list functions. So, excuse me, on PC2, we're going to go ahead and try to ping the server. So we're going to ping 2001:DB8:1:30:30. And you can see from PC2 that that's going to fail. Now let's try from PC1. And again, we're blocking all outbound traffic on this router 3 interface that's ICMP, right? So if it's ICMP, it's not going to work. And so let's try one more time. So 2001, let's make sure that this is functioning. DB8:1:30:30. And again, that traffic fails. So just as you would expect, that traffic is going to fail. So let's open the web browser up right now, and let's go to HTTP, and we're going to try, and in fact, it should still be in my buffer, I hope. Let's see. All right, so we're going to the right address there with HTTPS, and it works great. So let's clear out the HTTPS, HTTP, and HTTP works as well. So again, we're only blocking that ICMP traffic. So let me see if I can hop onto the switch here. And what happens if, let's just take a peek here, if I try to ping from the switch, 2001:db8:1:30:30:30. All right, so the protocol, the IPv6 protocol isn't running. Let's see if this is a multi-layer switch. And 2960, so not a multi-layer switch, and it has the LAN base. So if I was to try to enable IPv6 unicast routing, you can see that that command isn't even available to me. So if I do IPv6 and then a question mark, unrecognized command, and unfortunately what I was going to try to do is I was going to try to ping. And so let's do this. Let's hop onto router 3. So I'm on router 3, and this is another subtlety that you need to understand. So if I'm on router 3, and I am definitely running IPv6 because that's everything that we're doing here is IPv6. So if I try to ping, and Windows XP will not leave me alone about that update. So I'm going to try to ping 2001:db8:1:30:30:30. Let me make sure that's the right address. So from the router, I'm going to try to ping. So I'm on the router, right? I'm on R3, and that traffic is coming out of router 3, and I can successfully ping. And so here's another subtlety. Traffic that is generated on or by the router, right? So if I'm doing ping or if I'm doing trace route, right, that is traffic that the router itself is generating. That is not traffic that is passing through the router. And there's a major difference there. So I'm blocking ICMP outbound on this interface. And so the traffic I'm generating is actually coming outbound on that interface. However, it is not traffic that is transiting the switch, which you would say that would be data plane traffic. This would be control plane traffic that I'm generating by the ping command. And it's the same thing if I do the traceroute command, IPv6, and a question mark. If I type in 2001:db8:1:30:30:30, that traffic is also going to succeed. Because again, that is traffic that is being generated on the switch, not traffic that is transiting the switch. So let's check out, let's see what router 1 does. So if I go into, excuse me, from user exec to privilege exec, and I type in ping db8:1:30:30:30, you can see here that that traffic is not being allowed through. And in fact, the ping command is giving us A's, right? And so this is different output than we've seen in the past. When you look at the output from ping, right? And this is table 42 here. This is a great document on the Cisco website. If you simply Google for IPv6 ping output command, you can see the different output that you'll receive. And this is actually very good output here, very informative and indicative of what the problem is. So we saw A, which means administratively unreachable. Usually this output indicates that an access list is blocking traffic. And so that's what the letter A means in the output here. Because again, the traffic, even though it's being generated by router 1, that traffic is coming through these serial connections into router 3. So it's not traffic being generated by router 3. So as you can see again, if I ping from router 1, I'm receiving the letter A, telling me that the traffic is being administratively blocked, right? And so then let's pull this back up here. We won't do the trace route, we'll do our ping. However, here it succeeds, right? And so again, that's a subtle difference where if you have ACLs applied in the outbound direction from your router that you have that ACL applied on, traffic that's generated by that router is not going to be blocked. So we can still ping through from the router. Okay, that's another little subtlety there. So this has been IPv6 ACLs. We've configured them, we've applied them to the outbound interface on R3. We also did some additional testing. Hopefully this clarifies the confusion regarding the typo here with the prompt that you're going to see. And I will see you all this week. Have a great evening.